forces is nothing but a very fundamental concept or fundamental property of matter, which is called charge. So you know that you'd have been doing this experiment in your childhood as well, where you take a comb and then rub it against your dry hair and then bring the comb near to the um, uh, tiny bits of paper, and you will see that the bits of paper getting attracted towards the comb or the scale ruler, which plastic scale, which we otherwise use. So that's charge. So what is charge, my friend? Charge is a basic property of matter. So other basic.
I'm just kind of worried that turning the whole physics idea for lack of curiosity, I just mean wasting all this money, uh, this government funding on math equations that source a special kind of interest or spark a certain kind of curiosity. I don't know. This whole closed-minded uh, idea to stretch that the boundaries of creativity can't be pushed. Creativity, not storytelling, just reciting just a moral, a moral, moral after moral after moral. Um, because we know that they do in fact matter, and just because there is an invisible light spectrum or an invisible gravitational force happening, nobody will ever really intuitively be able to experience the little blue marble in its pure essence. And I'd say uh, that would be margin that would be marginalizing just how drastic uh, creativity can be pushed, and just in terms of it having no effect or this allusion to uh, somehow pushing Newton into the forefront, or just that this is a performance, an art form, uh, and not a critical sort of, in a sense, poetic uh, reckoning of human disappointment and demise, and how we can't really overcome certain aspects in nature, and that theoretically this wouldn't be the only thing that exists unless there was this singularity. Like physics shouldn't really have a chapter one; it should have a history.
Basic property of matter was mass. So charge is another basic property of matter. Now, by virtue of which they attract or repel each other, right? So do this experiment if you get time. So you take a small balloon and inflate the balloon and then rub it against dry hair, and then if the balloon is small enough, you will see that when you take it to the near a wall, it will get stuck to the wall. So that's the because of the difference in the amount of charge present on the balloon and the wall, you will see there is a force of attraction. Now we know by our previous knowledge there are two types of charges: positive charge as well as negative charge. And like charges repel and unlike charges attract each other. This is what we have observed in nature. And we also measure charge in terms of Coulomb. So this is the unit Coulomb. So charge.
And even without having a Sagan uh, polarity or an in-out electron, in-out uh, atomic uh, atomic definition of how electrons and protons work. or just how do we even have this nucleus, and then we have a nucleus with the protons, and then we have electrons spinning around. So how do we have an atom, and then we have charge? We're just saying that there's a good enough spectrum, or a good enough total recall of what's happening, and what's happening with the magnetism, and uh, or this dielectric, um, this polarization turning into electricity, this electromagnetism, and somehow modeling that models reality. Um, Again, it's a way to model, and I don't see how this isn't just the Protestant, uh, the Protestant way, like the original Christians, or something like. However Christianity actually works. I believe that the Protestants they try to do everything to the exact of original Christianity. So it's like this classical mechanics thing. Um, why does it matter, no pun intended, what definitions you're serving? And is it crucial to humanity, or is it really a performance?
Charles Augustine Coulomb was the person who gave the law of electrostatics, or the force of electrostatics relation. So, hence, in his honor, we have named the unit of the charge as Coulomb. Okay. Now, you can see there are two charges, positive as well as negative, and they attract each other. So, let's say if there are two negative charges, then they will repel each other, and if there are two positive charges,
And so I can understand this model, and how there's debasing going on with force, and that's pushing positive towards negative, and negative is being pushed to the opposite way, and that's how there's this oscillation.
then they will again repel each other. So, like charges repel, unlike charges attract. So, with this property of charge, now let's consider two charge particles. So, one is this one, the left one, the other one is this right one. One has a charge capital Q, the other one has small q. And let's say they are separated by a distance d between them. Okay, so they are separated by a distance d between their two centers. Now, this was Charles Augustine Coulomb who came up with this observation that these two charged particles, if they are unlike in nature, that is, one positive and one negative. So, let me say this is my negative charge and this is, let's say, positive charge. So, they will attract each other. If they are both,
So the positive is bigger. It just again, a negative force. So it's like already assuming the momentum effect, the photoelectric effect, in the sense that it is antimatter or elasticity dealing with a negative, and you have a positive, and it's a charge, and somehow the charge um, becomes um, the relevancy. And to say that there isn't special relativity or uh, general relativity going on, is an overkill, just because this is special relativity, the way I understand it, and the way I've been defined to see uh, the definitions I was taught to see special relativity. And just, again, having this negative force oscillating with a positive, uh, with a greater positivity pushing it. Again, already one piece. Okay, I mean this is just the beginning to ethereal theory, and then you have a positive bit, and that's being um, that's going to be being pushed out, and that could be your electron. But then this positivity is sucking the positive bit in. I mean, it's pretty clear just looking at one picture of it.
Of same nature, that is positive and positive, they will repel. If they are again both negative and negative, then they will repel again. But in this case, one is positive, one is negative, so they are going to attract each other. So you can see FAB is the amount of force by which the positive charge, A is attracting the charge B, like that, vice versa, right? So one force is, this force is being applied by whom? This force is applied by this charge here, and it is applied on whom? On this negative charge. So this negative charge is being pulled towards the right, towards the positive charge. Similarly, this positive charge is being pulled towards the left. So this is one fundamental.
In the sense, negative charge has a much bigger pull than positive charge having sort of uh, a negative push. Um, all the negativity is going into the positive charge, and the negative charge is uh, reinforcing all of the magnetism, sucking the positive charge in. I mean, it just because it's uh, you have two variables and there's no time, or I mean even I mean you have your distance. So it's just a contrivance to say that force wouldn't even be dealing with a distance, just in a complete theoretical sense.
Force which is existing in nature. So the moment there is charge on two particles, then they attract each other or repel each other. Now this is charge on body A, this is charge on body B. So this is the description, and this is D, distance between A and B, and this will be force on A by B, and this will be force on B by A. Okay. Now let's now understand the relation between the two forces. So hence, like what we saw in gravitational force, if